Hey everyone, and welcome back to this OpenZeppelin by example tutorial series. In this video, we're going to be checking out the Reentrancy guard. Reentrancy is one of the most classic um, types of vulnerabilities in the smart contract world. Um, Not typically seen much these days because there's so many safeguards against it, and people are, developers are much more aware of it now. But it really has cost several DeFi protocols millions of assets in the past. The way this works here is pretty simple. We have a flag called status, and there's two valid states, either entered or not entered. So by default, it's not entered. Then we add this modifier non-reentrant. It's basically calling these hooks here. So before the code is executed, we call the before hook and make sure that the status is not already entered. If so, it will revert and end the transaction, therefore stopping the reentrancy. But otherwise, it'll just execute the code and set the status to entered here, and then after the code executes, it'll reset the flag to be not entered. If you watched the previous video, you might remember this contract we made with the access control. One of the features of this contract was that it can handle deposits and withdrawals of ERC20 tokens. So I went ahead and copied the same contract over to new file here, but I purposely introduced some reentrancy vulnerabilities. So basically, when handling native Ether with either of these functions here, fallback and receive, that's what opens up the possibility of having reentrancy in this case. And reentrancy being, when contract A calls into contract B, then contract B calls back into contract A. That gives contract A the possibility of starting a loop, usually in which they will little by little drain funds out of contract B. So we have two withdrawal functions now, one with vulnerability and one that's guarded. They're actually totally identical. The only difference is the second one is using the modifier here. So what's causing the reentrancy is essentially that the state change is happening after, right here, the transfer. So always you want to do the state changes before transferring any balance or tokens or anything. But in this case, it's the wrong order. So if we put this in the right order, that would essentially mitigate that reentrancy in this case. But when you're dealing with assets and funds, it's always better to be safe than sorry. So might as well put this modifier just in case anyway. Also doing a little bit of fancy gas saving stuff here, putting this inside of an unchecked block, so that way this could theoretically underflow and go below zero, and then go back to some really high number or whatever it is. So in any case, I think I forgot to add this in the other function here. Might as well be thorough, make sure they're both identical. But yeah, so now aside from the contract here with the reentrancy vulnerability introduced to it, we have these two attack contracts. So we have one contract that's calling the vulnerable method, and the other one that's calling the method where it's going to be guarded. So other than that, these two contracts are identical. And as you can see here, the attack is initiated by withdrawing the funds. When the funds are withdrawn, it calls back into the receive method for this contract by virtue of sending Ether back to this contract, and then this receive method calls back into contract over here. So that's where the loop starts. So I have these unit tests set up already. Basically, we're going to just deploy the contracts, deposit a little bit of ETH from the deployer so that there's more funds in the contract other than just what the attacker is going to be depositing themselves. In this first test, the attacker is going to call their attack function, and we're expecting it to succeed because there's no reentrancy guard in place. So their balance after should be more than before, and this should be less than 1, although probably we can just have this be 0. Let's just change this really quick. So let's say to equal 0. Extra parentheses here. There we go. And we can actually go back into the attack contract, I think modify that too. Originally I was thinking maybe leave some dust or something because of some gas issues, but I think actually it should work if we drain it completely. So let's go ahead and change this condition to be equal to 0 as well. So once the balance reaches 0, that's when the attack will stop. I'll go ahead and do the same thing in the corresponding function down here as well. Okay, so the second function though, we're expecting that to revert with ETH transfer failed. that's the error that's going to be thrown from the contract holding the funds right here. The reason is when the errors are thrown, they bubble up to the top of the stack. So even though the Reentrancy Guard is going to throw this error right here, that's going to actually bubble up and then cause this require statement to also, basically get invoked, and then that'll be the actual error that's returned from the top of the stack. So we're expecting that error to happen here. Then after the transaction reverts, we want to make sure all the balances are still the same as they were before the attacker tried to steal the funds. So let's go ahead and run these and see what happens. Okay, everything seemed to go as planned. So you can see here the balance of the contract is a 5 ETH after the deployer puts their funds in the contract, and then when the attacker puts theirs in, it becomes 10. But then little by little through this reentrancy attack, they're able to drain all the funds. So now the target contract has 0, and the attacker was able to steal all 10 ETH that was being stored in that contract. The second one, we can see here that balances were the same beforehand. The Reentrancy Guard got triggered one time. The attacker tried to execute the attack, however, the guard blocked it, and then that's when the transaction got reverted, and the balances are still the same as they were previously. So that's all for this one, and hope to see you guys in the next one.